Now for this last example, we have beach sand is poured, creating a cone whose radius is always equal to twice its height. If the sand is poured at a rate of 20 cubic inches every second, how fast is the height changing at the time the height is 2 inches? So we have this cone that's being formed. With our sand, and then the radius is always equal to twice its height. So I'm going to write that down. Radius is always equal to twice the height. If the sand is poured at a rate of 20 cubic inches per second. So since they gave me cubic inches, that tells me I have a unit of volume. So that's the rate of change of volume. So I'm going to write down dV dt is 20 cubic inches every second. How fast is the height changing at the time? So how fast is height changing? So what is dH dt? That's what I need to figure out. At the time or at the moment when the height is 2 inches. So the height of this cone is going to change because the cone does get larger and larger. It does say the radius is going to stay a constant 2 times the height. So let's come up with the volume of a cone. When I say come up with, I mean you can Google the volume of a cone and come up with that formula. But the volume of a cone is 1/3 pi r squared times the height. Let's try that 1/3 again. 1/3. Now, is anything constant? No, the height, it does change, the radius does change, but it does tell me that the radius is twice the height. So this is a hint that tells me I can substitute in something for that radius. So I'm going to substitute in, for r, I'm going to substitute in a 2h, especially since I have there's an h measurement given and it's asking me for dH dt. I definitely want to leave the h in the formula, but notice they don't tell me anything about the radius, so I'm going to try to get rid of the r altogether by substituting r with the 2h that they told me. So now my formula will look like volume equals 1/3 pi times 2h squared times the height. Then I can simplify this formula. Volume is 1/3, let's see, pi. 2h squared would be 4h squared times 8, so 4h cubed. And then bringing everything together, volume would be 4/3 pi h cubed. So I've substituted in all the constant values and substituted in the 2h for the r. Okay, so now that I have everything substituted and simplified as much as possible, I'm going to go ahead and find a derivative. So dV dt equals, let's see, 3 times 4/3 would be 4 pi h squared dH dt. Then I can substitute in everything that I know. So I can substitute 20 in for dV dt, 2 for h, and then dH dt is what I am solving for. So then when I simplify that, I'll have 20 equals 16 pi dH dt. Divide both sides by 16 pi. Divide both sides by 16 pi. You'll have 20 over 16 pi equals dH dt, which is approximately 0.398 inches every second. So every second, the height of this cone is growing by about 0.398 inches every single second.